All right, guys, let's take a look here. So which one of these is not a function? Yeah, B, why? Yeah, 5 has more than one output. A is fine. There's some repeated outputs, but who cares? They each only get one. That one is. This one ain't because of this. It's got that branching off from 5. 5 can't get two things. That's not fair. What about part C? Is that a function?
No.
No, why? 9, yeah, 9 has more than one output. Do you see how you can write this in this form? 9 to 1, 9 to -5, and then 3 to -5. You can write it in this form. I mean, so they're all really the same problem. What about part D?
Yes.
Probably yes, because I just had to know. Yes, because there are no repeated x's. Every x value only goes to one y value. And of course, E I basically answered earlier. Yeah, no circle will be a function. Poor little circles. There's a place where it goes through more than one. There's a lot of places it goes through more than once. No, fails, the volts. Become English. And part F is fine. Yeah, there's no vertical line that goes through more than once. Function passes vertical line test. Sweet. Okay. All right. Now number 2 is your just substitution problem. Really, is the right way to look at this. People always freak out on part D, but if you do the same damn thing, the process doesn't give a crap what's in there. It's a letter, it's a number, it's a name, it's a happy face. So how do you F with -1? Which function am I going to use? First, second, third? First. Yeah, the F function. So F of -1 is going to be 2 times -1 minus 1. So F of -1 equals? Yeah, -2 minus 1 is -3. So what is the point that the F function goes through? -1, comma, -3. I love it. Okay. What about h of 3? I'm going to put it in here, probably enough. So 3 squared minus 1. 3 squared is 9 minus 1 is 8. Bam. So real quick, I mean, please, dear God, don't divide by 3. That doesn't make any sense. So H symbol by itself doesn't make any sense. It's sort of like me saying, what's this? You didn't give me a problem there. It's just a symbol by itself. It doesn't mean a damn thing. So you can't divide by 3. That doesn't make any sense. It's not multiplication. So G of 1, I'm going to plug it in there. So G of 1 is 1 minus 1 over, who cares? 0. Right? 0 divided by anything that's not 0 is 0. All right, how about the freaky one here? It's kind of funny. If h of x is x squared minus 1, h of m is m squared minus 1. Let it be that easy because it is. Bam. And then what's really beautiful about this is there's nothing to do. You can't simplify that. So you just leave it. This one freaked people out too, but you always go back to the idea. Domain, what's the idea of domain? It's all the x values that you can use. So if you look at G, is there anything you can't use? Exactly. So you could say x not equal to -5. You could say all reals except -5. You could even say, and the student who did this, I love it. Little tears come out. Oh yeah. Oh shit. So you can, everything from -infinity up to -5, or anything from -5 up to infinity. So I always look at this as saying skip. From -infinity to infinity, skip -5. You can use every real number except -5. That's what that third option says. Do you have to write it that third way? No, you don't. If you do it, will I give you bonus points? No, I won't. But I still will appreciate that. That's nice. All right, is everybody cool with that? So if I asked you the domain for the other two, what would that be? What's the domain of f? Don't overthink this. So 1 is the only thing you're allowed to put in there?
Negative infinity to infinity.
All real numbers, yeah. Is there anything I can't use? Is there any number that I can't double? No, I can double any number you want. What about h? Again, all real numbers. What was the only reason that g had a problem was because g has a denominator. And that leads to possible problems. These guys have no denominators, they have no roots, they have nothing that has a problem. Roots have a problem, like square roots have a problem with negative numbers. They have a big problem with them. Can't handle it. It's not what these are. These are polynomials. I don't know if you remember, polynomials are defined everywhere. They're defined for every value of x. Okay. How are we there with that problem? Please let that problem not be that horrible. It really is just substitution on the face of it. So number 3, we're using this function over here. What must f of -1 have been?
-3.
Yeah, if you look at -1, where's the output? -3, there you go. So what must f of 0 have been?
-2.
If you look at 0, where did they put the output? -2, kick ass. And then the domain, what would the domain be?
-2.
It starts at -3 and it goes up to 2. So the domain would be -3 to 2. But what about the range? Now this is a big question. Somebody had a good question about this, but the range is the lowest output to the highest output. So you don't say -2 to something, right? There's lower outputs than that.
-3 and 6.
Yeah, -3 is an output. That's the lowest output. And the highest output, 6. I love it.
Would it matter if you switch it?
It would.
Okay.
Yeah, that interval notation is always smallest, comma, biggest. Always. I like it. Okay. So I'm gonna do just a little bit more today. We might as well get a little ahead. It's awesome. So that we have more time next week for review. Well, that's the practice. Don't forget the practice test is on the back. Right, I'm going to have the answer key to this on Tuesday. All right. So let's just do a little bit more. See how much you can handle. It's an endurance trial here. It's basically what every summer class is. Now, the funny thing about Section 8.2, the reason I don't feel too bad about putting it in real quick today, is that it's just looking at lines, but looking at them as linear functions. There's only one line that's not a function. So most lines are functions, right? Is this a function?
Yes.
Yes. And so is this one, right, and so forth. What's the only line that would not be a function?
Vertical line.
Yeah, if it's a vertical line, it obviously completely fails the freaking vertical line test, right? So if it is a vertical line, we should have, like, what's the equation of this line? X equals 2. Does any vertical line go through that more than once?
X equals 2.
Shit. That vertical line goes through it an infinite number of times. It like over fails. It's like, whoa, dude, you failed already. Stop it. You guys with me? So most lines are functions. So we got this idea of linear functions. So really, most of this section 8.2 is going to be old stuff about slope and stuff. Let's see if they throw out some more interesting stuff. Oh, here we go. markers since we can. Little dudes. Okay, so help me out. Let me see if you guys can do this. This is interesting. I like this. So X, Y. Man, I'll make an XY table sideways because the book likes to do that. If I put a 1 and a 3 there, and then I put a 2 and a 7 there, don't say this out loud. Sit on this for a minute. And this is a linear function. This has to be a linear function. I think what would be here? Take a second. I didn't say something that was wrong here. So what's got to be true about a linear function? What's give me a fundamental truth about any line? 11. Okay, yeah, it is. It's 11. Why? What's got to be true about a line? Yeah, the someone's got to be saying it's the constant slope. If the slope changed, it would curve, not a straight line anymore. Slope has got to be constant. All right? So just to freak you out for a second, all calculus is the study of slopes of things that aren't lines. There's still a slope, it's just the slope is changing for the parabola, right? Do you guys see that? So the slope is positive, and then it's 0, and then it's negative. So that's what calculus is how do you determine what the slope is for something that's not a straight line? So that's not what we're doing. I just like to sneak that in when I can. So when x changed by 1, y changed by 4, it better do the same damn thing again, and again, and again, and again, and again, and the other way too, or else it's not a straight line. So x changed by 1, y's got to change by 4, that would have to be 11. So what if I gave it problem to you the other way? Is this a linear function?
No.
Why not?
Because you go down by 4 from
Like-
the name.
Yeah, if I go down by 1, I go down by 3. So if I go down by 1, I better go down by... Oh, shit. I didn't go down by 3 that time. So that would not be a line. It would have a kink in it, right? It'd be curved somehow. Yeah, I like it. Maybe. So not, so you say not linear. So there's a whole little section in the homework that just gives you a bunch of these and says, tell me if it's linear or not. So when a student looks at that and I didn't say anything about it, like, what the hell, how am I going to tell this shit out? That's the key, is what's got to be true for a line. Slope's got to be constant. That's what's got to be true for a line. Okay. Let's see, what other funkiness do they put in here? Blah, 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 blah. Oh, let's see. Oh, good, I love it. Let's see, I might as well put, yeah. Ooh, I like it. So is this a linear function? Is it a linear function? No. But I could talk about like a line through those 2 points, right? Like I was just talking about, I could say, as you go around a parabola, the slope is always changing, right? So get a feel for the rate of change. I can talk about the straight line through those 2 points. What would the units be on the slope? What's slope again?
Rise over run.
Rise or run. Now break it down to me in terms of axes, in terms of variables.
Energy over temperature.
Oh, okay. So it'd be y's over x's, right? So the slope is the y's over the x's. And in terms of units, that would be kilowatts per degree Fahrenheit, right? So a slope, if you haven't been told this before, if your Math 90 teacher didn't say this, slopes are always rates of change. You with me? So this tells me how much, so the slope at some point tells me how much it's changing. As the temperature changes, how much is the energy use changing? So obviously as the temperature, if it's really cold, and this is really cold in San Diego, right? If it's really cold, then people use more energy. As it warms up, they're going to use less and less energy, right? And then, of course, as you go around the corner, when it starts to get hotter again, they're going to use more and more energy. I like it. So at this point, if I change the temperature, if I increase the temperature, the energy use goes down. So back here, the slope is negative. Over here, the slope is positive. I love it. So if I give it to you again in this, if I told you that these x's are, you can do it, Jeff, ages of children and the thousands of words known. You can do thousands, Jeff. There you go, buddy. You guys kind of with me? So at age 1, the kid knows 3,000 words. At age 2, they know 7,000 words. I don't know if that's true or not, but go with me. If that's what it was for this one kid, right? The slope would be what? We already know what the slope is. What was the slope again? It was 4 over 1. Y's over x's, right? So 4,000 to 1. What would the units be? Age of years. Y's over x's. So it'd be
Words.
thousands of words per year. So it'd be how many words per year this kid is picking up. Let that sink in. Every time you do a slope, it is a rate of change. Because it's y per x. One of the simplest ones is the graph of how much money you make in a constant wage job. So if you're making $10 an hour, or my first job I was making $3.20 an hour. Of course, gas cost 98 cents. Yeah. God, I feel too bad. $10 an hour. So here's your line equation. And $10 an hour. So this is the money you make. I'm sorry, yeah. This is the hours you work, and this is the money you make. Right? So it'd be dollars per hour. Every time you do a slope, it is a rate of change between these two things, whatever they represent. Maybe. So that idea of slope is rate of change is really kind of hit on a lot in this section because it's really important. Let's see. There was one other thing to do. No. Nah. No. Well, yeah. Okay. This is the last thing, and then we'll head out. What time is it? It's not. Well, that's not too bad. I seem to be okay with leaving a little before 2. Hopefully you're okay with that too. Mm-hmm. Somebody's going to go to the dean and say, this guy's not giving me my money's worth. What's wrong with him? It could happen. I don't know. Shit. One more thing that's in here is the midpoint. Something called the midpoint between 2 points. So if my points that I'm talking about were right across from each other, like this, the idea of midpoint, stupid easy. What would be the midpoint for this? 3, 0, right? That's 1, 0, that's 5, 0. The midpoint would be 3, 0. Is that cool? So what if I add the points on this axis? What would the midpoint there be?
0, 2.
0, 2. I love it. So here would be the midpoint. 0, 2. All right, now, please. Is that cool? I mean, that's If they're directly across from each other, if they're not and when they get diagonal, that's where you might think it's going to get really difficult, and it doesn't. But this one, you can see it's not difficult. Just what's the middle of those? If I give you something gross, some gross number here, how would you actually do it? You would just take the, you could do it. How do you get 3 here? You actually take the, how do you find the middle of any two numbers? You take the average. Yeah. You add them up. 1 plus 5 is 6 divided by 2. Hey. 1 plus 3 is 4 divided by 2. Hey. Okay, so even if the numbers are gross, you can still do it. You just take the average. So what if my points were the point 1, 1? No, Jeff, you want to do a different color. Good job, buddy. 1, 1 and the point 5, 3. The midpoint is just the middle of both. That's awesome. So the midpoint of things that are diagonal from each other is just the average x's, comma, average y's. So if I'm given points, so this midpoint would be the point 3, 2 in between these points. So if I'm giving a point x1, y1 and a point x2, y2, how do you find the midpoint? It would just be, get out of there, weird ass thing. It would just be x1 plus x2 divided by 2, the average x. y1 plus y2 divided by 2, the average y. That would be the midpoint between those 2 points. Almost too nice to believe. Because when you go diagonal, you're like, oh shit. Do I have to have Pythagorean theorem? No, it's not about the lengths of these things. It's just about finding the middle of these 2 points. It's a lot easier than good old Pythagorean theorem. Right? Okay. So I want to point out something real quick. Any questions on that? I didn't feel like I would have to say too much more than that on that. That was one little thing at the end of that section. What was the other thing? On Monday, I'm going to bring some graphing calculators. If you haven't gotten one yet, you might want to get one. You can rent one, like I said. So on Monday, we are going to devote some of the class time after the quiz to just looking at some basic stuff on the graphing calculator. Right? So we're getting into graphing a little bit. That's obviously going to come in handy for a few problems. Don't forget, again, the practice test. The actual test would be at most this long, I think. I mean, this is decently long. I'm not going to give you the entire class time for a test normally, but, you know, it's going to be a good couple hours, maybe, not the whole time, right? So on Tuesday, I'll have the answer key for this. Cool. Okay. If you have any homework that you didn't turn in, just go ahead and turn it in. Anybody not get their quiz back?
How many questions will be in the test?
Oh, I don't know. It's like, I'd say 25 to 30, counting ABC. Right?
I didn't get my quiz.
Oh, okay. Oh, is that yours too? Yeah, it's yours too.
Quiz will be all the sessions.
No. Quiz appendix D through 7.2.